Hello students, as you know we are dealing with very interesting chapter of science, that is chapter 10, light reflection and refraction. In the last lecture we studied ray diagrams for concave and convex mirror. Now in this lecture we will see the uses of concave and convex mirror and the difference between concave and convex mirror. Along with this we will see sign conventions and magnification of spherical mirrors. So let us start with our lecture. Uses of convex mirror. First of all, let us recall which type of image is obtained by convex mirror. Convex mirror always gives virtual image, and that virtual image is diminished in size and it is erect. So since it gives erect, virtual and diminished image, it is used in security mirrors, side view mirrors in cars, etc. So students, let us see the uses of convex mirrors in detail. Convex mirrors are commonly used as rear view mirrors in vehicles. We have already seen in the diagram, right? These mirrors are fitted on the sides of the vehicles, enabling the driver to see the traffic behind him or her to facilitate safe driving. Now, why convex mirrors are preferred? Because they always gives erect image, though diminished image, means it gives erect and diminished image, so they are preferred. Also they have a wider field of view as they are curved outward, means many vehicles can be seen at a time. Thus convex mirrors enable the drivers to view much larger area than would be possible with a plane mirror. Why plane mirror? Because plane mirror also gives virtual image, but its size is same as that of object. Because of that, instead of plane mirror, convex mirror is preferred as rear view mirror. Students, it can be asked for 2 marks. Explain why convex mirrors are used as rear view mirrors. Then you have to write all these things. Next is uses of concave mirrors. They are used by dentists, in torchlight, in solar cooker, in parabolic reflectors, and in headlight of cars. So, uses of concave mirrors. Concave mirrors are commonly used in torch, street light and vehicles headlight to get powerful parallel beams of light. They are often used as shaving mirrors to see larger image of the face. The dentist use concave mirror to see larger image of the teeth of the patients. Large concave mirrors are used to concentrate sunlight to produce heat in solar furnaces. Students, you know concave mirror also gives virtual image, but it is enlarged. So because of this they are used as shaving mirrors or they are used by dentists. So students, now let us see the difference between convex mirror and concave mirror. First one, convex mirror is a spherical mirror whose reflecting surface is away from the center of the sphere of which mirror is a part, which means that it has outward reflecting surface. Concave mirror is a spherical mirror whose reflecting surface is towards the center of the sphere of which mirror is a part, which means that it has inward reflecting surface. Second, the focus lies behind the mirror, the focus lies in front of the mirror. Third one, convex mirror is a diverging mirror. To diverge means to go away, and you have seen that when light rays are incident on convex mirror, then after reflection the reflected rays go away from each other. They are not meeting each other. Therefore, convex mirror is a diverging mirror. Concave mirror is a converging mirror. To converge means to meet, and you know that when light rays are getting incident on concave mirror, then after reflection they meet each other at a point and real image is obtained. So it is a converging mirror. In the fourth point, they have given the shape of convex and concave mirror. Here instead of that you can write the uses of concave and convex mirror also if you want, or you can make it as another point also and you can include this point. Fifth one, convex mirror always form virtual, erect and diminished image. Concave mirror form different type of image depending upon the position of the object, but there is an exception. It can't form virtual and erect image which is magnified or same as object. Now students, the next topic which we are going to study is Sign conventions for spherical mirror, and before that let us revise the Cartesian coordinate system which we studied in 9th standard. You know that x-axis and y-axis intersect each other at O, which is called the origin. You can see here on the right hand side of the origin positive values of x are taken, left hand side negative values of x are taken. On the upper side of the origin, positive values of y are taken, and on the lower side of the origin, negative values of y are taken. So if any measurement is taken with the help of this Cartesian coordinate system, it will have signs according to this. So students, now let us study sign conventions for mirrors. It is very important while solving the numericals. So first of all, let us see the first figure. Here you can see mirror is there, which can be considered as the origin of the coordinate system. If you compare it with the origin, then you can see that measurement which is taken on right hand side is positive, on left hand side is negative, on the upward direction of the mirror is positive, and on the downward direction of the mirror is negative. First of all, let us see the sign conventions for concave mirrors. Here you can see that I have drawn a Cartesian coordinate system in such a way that its origin is coinciding with pole P of concave mirror. Now we know that object is always placed towards the left of the mirror, right? So here you can see that object is marked beyond C, right? So if we measure the object distance from P, it will be negative because it is in minus x axis. Understood? And height of object will be positive as it is on plus y axis of coordinate system. Now let us see the image. In the concave mirror, real and inverted image is obtained for all the 5 cases except the last case, and it is on the same side of the mirror. So image distance will be negative as it is in minus x direction, and height of image will also be negative as it is in minus y direction. Now students, you know that for concave mirror, principal focus is obtained on same side of the mirror, so focal length will be negative. Now let us see the third diagram. Here also I have drawn the Cartesian coordinate system in such a way that its origin coincides with the pole of the convex mirror. Now let us see the sign conventions for the convex mirror. Object is placed on the left hand side of the mirror, so the object distance will be negative, and height of the object will be positive as object is placed erect. Now you know that image obtained in a convex mirror is behind the mirror and it is virtual and erect. So object distance, that is distance of the object from the pole of the mirror, will be positive. Image distance, that is distance of the image from the pole of the mirror, will be positive, and height of image will also be positive as we are getting erect image. And you know that for convex mirror, principal focus is obtained behind the mirror, so focal length will be positive. So students, these were the sign conventions for concave and convex mirror. Sign conventions for reflection by spherical mirror. While dealing with the reflection of light by spherical mirrors, we shall follow a set of sign conventions called New Cartesian sign conventions. In this conventions, pole of the mirror is taken as the origin, principal axis of mirror is taken as x-axis. This you already know, we have seen in the last slides. Now the sign conventions. First, object is always placed on the left hand side of the mirror. This implies that the light from the object falls on the mirror from the left hand side. Second one, all distances parallel to principal axis are measured from the pole of the mirror. All the distances measured to the right of the origin, that is pole in case of mirror, are taken positive, while those measured on the left side of the origin, that is on left side of the pole, are taken negative. Fourth, distances measured perpendicular and above the principal axis, that is along plus y, are taken positive. Fifth, distances measured perpendicular to and below the principal axis, that is along minus y, are taken negative. Now students, let us tabulate the sign conventions for concave and convex mirror. This table is very important for solving the numericals. First of all, you have to keep in mind that object distance is denoted by u, that is distance of the object from pole is denoted by small u. Distance of image from pole, that is image distance, is denoted by v. height of object is denoted by h and height of image is denoted by h dash. So first of all, let us see concave mirror. For concave mirror u, that is object distance, will be negative. Image distance v will be negative for real image, that is for first 5 cases, and will be positive for the last case since it gives virtual image. Focal length f will be negative. R is the radius of curvature, which is double the focal length you are knowing, which will also be negative. Height of object will always be positive. Height of image will be negative if it is real, and it will be positive if it is virtual. Now for convex mirror, u will be negative, that is object distance, since you know that object is always placed on left hand side whether it is a concave or a convex mirror. Image distance will always be positive since it gives only virtual image. Focal length will be positive, radius of curvature will be positive, height of object is always positive for both the mirrors because we always keep object erect. Height of image will also be positive since it gives virtual image only. So students, here you can see that object distance u is negative for both the mirrors since mirror is always placed on left hand side. So whether it is a concave or a convex mirror, u will always be negative, and height of object will always be positive since object is always placed erect. Focal length will be negative for concave mirror and positive for convex mirror. Now our next topic is magnification for spherical mirrors. First of all, what is magnification? Magnification for spherical mirrors is the ratio of height of image to height of object. So we can say that magnification gives us the height of image as compared to height of object. So its formula is magnification m is equal to height of image upon height of object, that is h I upon HO, which can also be written as H dash upon H, where H dash is height of image and H is height of object. Now magnification is also related to object distance and image distance, and it can be obtained as magnification for mirrors m is equal to minus v upon u, where v is image distance and u is object distance. Now students, we know that magnification is height of image upon height of object, that is equal to h dash upon h. Now if we consider concave mirror, for concave mirror height of image is negative, we have seen in sign convention, since the image obtained is inverted and height of object is always positive. So if we take the magnification, that is ratio of height of image to height of object, it will be negative upon positive, which will have negative value. So for concave mirrors, value of magnification will be negative since it gives real and inverted image, that is for first 5 cases. Now for convex mirror, h dash, that is height of image, is always positive because we are getting erect image, and height of object is positive obviously. So magnification m is equal to h dash upon h will be positive upon positive, that is equal to positive. So if the value of magnification is positive, it represents virtual and erect image because it is for convex mirror, and convex mirror gives virtual and erect image. So we can conclude that if magnification is negative, it represents real and inverted image. If magnification is positive, it represents virtual and erect image. Now let us see the size of image with respect to magnification. If magnification is 1, that is value of m is 1, it states that size of image is same as object. Now students, let us see how. M is equal to h dash upon h. If size of object and image is same, then h dash upon h will be 1. So if m is equal to 1, size of image and object is same. Now if m is smaller than 1, it represents diminished image. How? Suppose that we are getting image as 2 centimeter, height of image is 2 centimeter, and height of object is 4 centimeter. If we find magnification, it will be 2 by 4, that is equal to 1 by 2, which is equal to 0.5, which is smaller than 1. So we can say that in any case, if m is smaller than 1, that is height of image is less than height of object, then it represents diminished image. Now if m is greater than 1, it represents magnified image or enlarged image. Let us consider the example. Suppose that height of image is 10 centimeter and height of object is 5 centimeter. So if we take h dash upon h, it will be 10 by 5, which is equal to 2, which is greater than 1. So generally, if m is greater than 1, then it represents magnified image. So students, you have to remember these things related to magnification, which will be helpful to you in solving the numericals. Now students, this example will be very much helpful to you in understanding the magnification clearly. So first of all, here is a table in which values of magnification are written, with respect to which we will get nature and size of image, and we can say type of mirror also. Let us see how. Consider the first case. Here magnification is +1. Now students, you have to keep in mind that whenever magnification is given, first of all you have to see the sign. With the help of this sign, you will be able to know the nature of image, and then you have to see the number, with the help of which you will be able to know the size of image. So here +1 is there, plus sign is there, which represents virtual and erect image, right? We have seen. And 1 is there, and we know that if m is equal to 1, then it represents that size of image is same as object. You can see in the column virtual, erect and of same size as the object, and this type of image is obtained by plane mirror only. Consider the second case. Magnification is -1. First of all, you have to see the sign. It is negative, and you know that negative sign represents real and inverted image. And 1 is there, which represents same size. So it is real, inverted and of same size as the object. Now we know that concave mirror only gives real image. So whenever you see real image, mirror will be concave mirror. Now the third case, magnification is +0.5. Plus sign indicates virtual and erect image. Now 0.5. It is smaller than 1, and we know that when magnification is smaller than 1, it represents diminished image. So the image is virtual, erect and diminished, and we know that convex mirror gives virtual, erect and diminished image. Fourth case, -0.5. Minus sign represents real and inverted image. 0.5 means smaller than 1. If magnification is smaller than 1, it is diminished image. So the image is real, inverted and diminished, and since it is real image, the mirror will be concave mirror. Now fifth one, +5. Plus sign indicates virtual and erect image, and 5 is greater than 1. So if m is greater than 1, magnified image is obtained. So the image is virtual, erect and magnified. And the only mirror which gives this image is concave mirror, and this is the only case in which concave mirror is giving virtual image, that is virtual, erect and magnified. Now the last case, if magnification is -5. See students, here you need not have to consider -5 means smaller than 1. For nature you have to see the sign, and for size you have to see the number. Minus sign indicates real and inverted image, and 5, which is greater than 1, indicates magnified image. So the image is real, inverted and magnified, and the mirror which gives this image is concave mirror. So this way, if the value of magnification is given to you, you can identify the nature of the image, size of the image and type of the mirror also. So students, we conclude our lecture over here. In this lecture, we studied uses of concave and convex mirror, difference between concave and convex mirror, sign conventions for concave and convex mirror, and magnification. Prepare it well and write the notes